So this is transformations 3.2, stretching when shrinking. So we want to make sure that you are able to handle both horizontal and vertical stretches and shrinks, be able to like tell what's going to happen, and then actually be able to graph them. So here is a function. Instead of saying it's like absolute value of x, we made you this, which we sometimes call a sawtooth function because it kind of looks like teeth on a saw if you got up really close to it. Okay? Kind of looks like a mountain range too, right? So I can take this and I can move it all over the place. That's what you already know how to do. Like if I said to the right 3 and up 1, it would look something like that. You've already done that. We've also flipped them. And a left-right flip would make this thing like go over this way. And an up-down flip, a vertical flip, would make it go this way. But what about a stretch? All right. First of all, this says y equals f of x. So what is that? That's the original function. Put an x and a y right there. What we need to do is start by keeping track of what are the original points. What do I start with? So this is one of the points, 0, 0, so put that on the list. This is one of the points, 1, 1, put that on the list. This one's 2, 0, and keep going. 3, 1, and 4, 0, right? Okay. Now, if this original function got changed to this, I'd like you to think, obviously it involves a half. Question is that going to be half as tall or half as wide? Or could I trust it? Or is it the opposite of what it seems? And therefore, instead of half, it would be double. Okay, so first of all, horizontal or vertical? Vertical, it's on the outside. And the next question is, if it's vertical, can we trust it? Yes. So it seems like it should be half up down. That's also known as your height, is your up down. Okay, so it's half the height. So that means the new points for this thing, if you just think about it, it's going to be half as tall as it used to be. How tall was that dot in the first place? 0. So its height is half of that, which is still 0. How tall was this dot? It was 1, and now it's going to be half of that. So it's going to go like this. Do you get that that function is now half as tall as it used to be? All right. The common mistake is people think it moves down when you do that. Really think about it. Do you get the base of it is still in the exact same spot? Now, it got shorter. It did not move down. It got shorter. Half as tall. Yes. All right. Did I change the x? I didn't change the x. I changed the y. All right. So let's talk about that. For this first point, as it went over to here, did I take half of the x or half of the y? Half of the y, because the y is how tall it is, right? In fact, the x's, would you agree, are just going to exactly stay the same? The x's are going to be 0, 1, 2, 3, and 4. X's aren't changing. What could I have done? I could have taken the original points and take all of the y values and do what? Cut them in half. Because this height was 1, now it's a half. It's the y value that was changing. This 1 is changing to a half. Half of 0, the first point is still 0, so that doesn't change. Half of 0 is still 0. That's because that point right there doesn't change. This point didn't change. All right, this one changes from 3, 1 to 3, 1 half. And the last one is 4, 0 changes to, it stays the same at 4, 0. See, it's still there. Does that make sense to you? All right. Now this one. Is that too a vertical or horizontal thing? Vertical. You wouldn't believe how many people, when they were taking the test yesterday, were asking me something like this. Is that 2 on the inside or is it on the outside? How can you tell if something's on the inside or the outside? If it's inside, it has to be in parentheses or inside something. Okay, otherwise it isn't inside. All right, so that's on the outside. Now, it doesn't have to be inside parentheses. It could be inside a square root, like that. Now, that would be, obviously, the 2 would be on the inside. All right, so that 2's on the outside. And so it's a vertical. It's a VO, high VO, right? VO, vertical on the outside. That's a vertical change. So I'm going to go back to the original parent points, which are right here. And which are changing this time? The X's or the Y's? Well, what am I messing with? Am I messing with its height or its width? I'm messing with the Y's. I'm messing with the height. Okay? I messed with the height last time. I'm still messing with the height. Except this time I'm making the height twice as big. So my X's are staying the same. 1, 0, 1, 2, 3, and 4. Do you get why the X's are staying the same? Because the X's control left, right. And my X stuff in here, nothing happened inside, so I leave my X's alone. Something happened on the outside. That's where the vertical or the Y stuff happens. So that makes it twice as big. So I take all of these numbers here, 0, 1, 0, 1, and 0, and I do what to them all? Double them. I make them twice as tall. So 0 doubled is still 0. 1 doubled, this one right here doubled turns into 2. 0 doubled is still 0. 1 doubled is 2. And 0 doubled is 0. There we go. Guess what happens when I graph those points? What shape's it going to make? Same shape, sawtooth, except what? Going to be taller. So let's graph those points. Everybody graph those and compare your result with the kid sitting next to you and see if your little picture looks the same as their picture. Okay, so you should have had a function that goes up twice as tall as it was in the first place. So up to there, back down to there, up to there, back down to there. Does that make sense for a vertical stretch? All right, let's move on. Everybody go to the next page. Look at the difference. What's this page? How is this page different? What are we doing different? It's on the inside, and therefore it's horizontal. It's horizontal, and therefore we are messing with the X's or the Y's? The X's. Now, the original points, again, I would list them if I were you. Okay, on this screen, 0, 1, 0, 1, 0, 2, 0, 3, 1, and 4, 0. Now, I'd like you, without my help, to try to figure out what the new points should be. Remember, one of those, either the X or the Y, is just going to stay the same. And the others are going to be different. And I want you to see if your gut feeling on what to do here is right. When you're done, you actually graph. So why don't we just start with this one. See if you can get that one done and then sketch where you think it is, or graph where you think it is, and then compare it with the kid sitting next to you. Yes?
Shouldn't it be 1, 1, not 1, 0?
You're right. Thank you very much. That is not 1, 0. It's 1, 1. Very good. Good catch. Because on the original parent one, this dot right here is at 1, 1. Thank you. Okay. So now, either all my X's stay the same or all my Y's stay the same. I go over, I make a new set of points, I graph those points, and hopefully the thing does what you expect it to do. I'm going to pause for a second while you try that. Okay, thanks for your patience on that. Now, let's see if you did it right. X is the thing we left alone last time, so you kind of logically figure we were going to probably mess with X this time. And also, you can look right in there. That's a horizontal thing. That changes X. Could you do that? Thank you very much. So this is 0. I'm just going to rewrite the original for a second. 1, 1, 2, 0, 3, 1, and 4, 0. And I'm going to change my X's this time. So I'm going to take each of my X's and times it by 1/2. Times it by 1/2. Times it by 1/2. Isn't anybody going to stop me? Times it by 1/2. Why don't I multiply it by 1/2? Don't trust the things on the inside, and therefore you multiply it all by what? By 2. Excellent. I was hoping somebody would say, but wait a minute. Okay, so this is 2 times 0 is still 0. This is 2 times 1, which is 2. This is 2 times 2, which is 4. 3 times 2, which is 6. 4 times 2, which is 8. If I graph all those spots, 0, 0 is still here. 2, 1 means over 2 up 1 is right there. 4, 0 is over 4 up 0. That's at this spot. 6, 1 and 8, 0. And look at that. It got all stretched out. Twice as wide. Does it make sense that it's twice as wide? It seems like it's supposed to be half as wide. But you don't trust it. It makes it twice as wide. Okay. Now I'm going to go back to the parent points again. And I'm just going to start by writing the parent points down. 0, 0, 1, 0. No, 1, 1. Sorry. I keep wanting to say that's 1, 0. 2, 0, 3, 1, and 4, 0. Now, should I leave the parent points alone? Only if I didn't touch anything. But I touched the inside, which is the x's, and I doubled my x's, so what do I want to do this time? I don't double them. I can't trust it. I can't times everything by 2. I times everything by 1/2. 1/2. 1/2. Once you got that done, graph it. Use a different color this time. That's part of the benefit of an iPad is you don't have to just keep using black or blue or whatever color you like to use. Change colors. And see what it looks like when you're done. Okay, so how did this one look when it was all done? You know what? I don't even have to complete all those points because I know logically where this is going to end up. 0, 0 isn't going to change, right? And then it's all going to what? Shrink or stretch? Shrink. And which way is it going to shrink? Inwards, yes. It's going to be half as wide as it used to be. So the M used to end right here. What's half of that? Right here. So I'm going to make it half as wide. And then I'm just going to say, okay, now here's a common mistake. People go, okay, so I'm going to make my M like this. I just made it half as tall also. Is that what's supposed to happen? No, it's supposed to be half as wide. It's supposed to be the same height. So how do I make it the same height? Well, I go half, and let's see here. There we go. There's my M, the same height, but half as wide. All right. I hope that's making sense to you. This is one of those funky shapes again. And do you remember last time when we did these on the test even? We had something like this, and we don't know what it's called. And I had told you before that, like if you don't know what it's called, you could say, you throw in an F instead of like absolute value of the function, like this. It's been moved to the right and whatever. Well, we don't know what's absolute value, so we don't say absolute value. We'd say what? F. So if we don't know what this is, we call it f of something. Okay? Now, f of what? Well, in this case, this is the parent function. This is f of x. That's just its name. It's f of x. But what if I move that parent function somewhere else? Let's say I grabbed it and moved it. Oh, let's keep it simple first. We'll just move it like down 1. So if I take this and move it down 1, boop, how do I write that? Some of you forgot the F. I think I only moved it down 1 though. -1. Yeah, it's all right. You had the exact right thing and just moved it down too far. I moved it down 1, and mine isn't perfect. This should be, it looks like it should go a little higher there, but anyway, like right up in there. Okay. So you take your f of x, and you got to throw the f in there. Why do we have the f in this function? Because we don't know what the function is. We don't know if it's absolute value. We don't know if it's square root. We don't know if it's squared. So we don't include any of those. We just say f. All right, that was one of the number 1 mistakes on the test is people forgot that you'd have to throw in the f to get your answer if you don't know what the function is. All right, so back over to this. Why do they want this 1/2 f of x thing? Well, that's what the problem is. They're asking you to do something to this function. What are they asking you to do to it? Make it twice as wide, half as tall. It's a vertical. Is it a stretch or a shrink? Vertical. So shrink. Half as tall, vertical. Vertical means up and down. Half You can trust stuff on the outside, so half as vertical, half as tall. So you could just take every dot and make it half as tall, but keep the width the same. So I'll take this dot and move it down here. See what I did there? Made it same width, but half as tall. And take this one and move it down half as tall. This one used to be 3 tall right there. So we go down half as tall. Where's that going to go to? 1.5, yep. And then this one used to be 1 tall, and now it's only a half. No, it was half as big, half as tall. This one's -3 tall, and so we go half of that. Notice I'm not going to go down further. This was -3 tall before. Now it's -1.5 tall. It's right there. Now it's totally okay to do it the way I just did it. Or you could get the parent points and do stuff to them. Let me show you what it should look like. Oops, I got to get a curve in this. It's tricky to do. There. You can imagine that the end of that function is where usually I see the mistakes, because people just feel like the whole thing's moving down. It's not. It's moving towards the middle. So the stuff that was down low has to go up. The stuff that was up high has to go down. Okay, so what would that look like in terms of points? Well, we should probably write down what the parent points of this thing are. I'm going to make an XY chart right here, and I'd like you to do the same. Make an XY chart of the parent points of this thing. -3, 4. And then -1, 1. I'll help you make the list. I would make the top of this circle into a point. 1, 3. You can make any spot that you know is on there. You can make any spot you know into a spot, onto a point. 3, 1. And the next one is 6, -3. And now, to do that 1/2 on the outside, I'm going to recopy all these parent points over here. And if I left it alone, that means I don't want to change it at all, right? What do I actually want to do to this? So the X's or the Y's are the ones that need to change. Y's need to change. Do you want to trust that and do half the Y's? Yes, because it's the stuff on the outside, so you can trust it. So you do half of the Y's. Half of this, half of that, half of that, half of that, half of that, and I bet you it works out to be the exact points that we have. 4 times a half is 2, is -3, 2 on our graph. Look at that, -3, 2. It's on the right spot. So if you're more the type of person who wants to take the shape and say, okay, I know what's supposed to happen here. It's supposed to get half as tall. So I'm going to do that with all my points. That works. I got it that way the first time. This was the trickiest part because it was down 3. Now it has to be down only 1.5. But if you want to do it with points, there's that last point. -3 times a half is -3 halves, which is -1.5. So, all right. I think you've got the idea. Would you please go to this one? It's a light green color slide. This time, I'd like you to do it with parent points. Would you write down what the parent points are for this graph? I'd write them right in here. And then just remember you've got to change them by doing this to something. Okay, so write down the parent points, then do something with the 2 to all those parent points. Like -3, 4 is your first parent point, etc. I'll pause for a second while you give that a try. Okay, I just had a student come up and write down the parent points in red. Awesome. Now all of these green numbers looks like you changed your X's. And that makes sense because we're in here with the X. That's a horizontal thing. And that's a horizontal, looks like it should be, it should be twice as big, shouldn't it? It's got a 2 in there. Why didn't you multiply everything by 2? Can't trust the inside, and you do the opposite of that, and therefore you cut them all in half. So 3 turned into negative 1.5. Negative 1 turned into negative a half. And when you graphed this thing, did it get wider or narrower? Narrower. Good. So like we graphed negative 1.5 comma 4. Negative 1.5 comma 4 is right there. And look at that. That dot is half as far over as the red dot was in the first place. Its width changed. Its height stayed the same. All right. And so you do that with each of these points. And this point moves over here. This point gets half as far over. And then this point gets half as far over. It was over 6, now it's over 3, is right there. So it should look something like that. It got squished. A vertical squish. No, a horizontal squish. There we go. Okay, so it didn't get stretched, it got the opposite of stretched, which we usually say shrink. Okay, so our horizontal shrink. Raise your hand if you feel like you understood that. That made sense to you. Okay, good. So that's all there is to it. We're going to describe these in words. So get to the kind of the grayish color slide. And to describe this in words, the very first one is a trick one. Only because it's dividing x by something. Well, how about this? I'm just going to rewrite this as y equals something x. What is x over 4 the same exact thing as, but it might make more sense this way? 1/4 x. Do you get 1/4 x and x divided by 4 are the same thing? All right, good. Now, do you get that this x has been multiplied by 1/4? And now you got to think it through and say, okay, it seems like it's 1/4 of the x. So you don't do that. What do? 4 times the x. Good. So this thing is getting 4 times the width. So you'd say it in words, 4 times wider. But I'd want you to say it with words like stretch and shrink and words like horizontal and vertical. So is this horizontal or vertical? I keep talking about on the inside and on the outside, right? What's on the inside? Horizontal on the inside. So this is a horizontal, what? Stretch. Seemed like it's shrinking, but it's stretching. And you have to use the word factor. And now this is a tricky part. Would a stretch factor of 1/4 seem a little backwards to you? I hope so. You shouldn't say stretch a factor 1/4. It's a stretch factor of 4. You have to change this around because you're describing it and you can't trust this 1/4. So you have to describe it as a stretch factor of 4. It's 4 times bigger. So anytime you use the word stretch, your number better be bigger than 1. If you use a stretch factor 1, you didn't change it at all, right? Stretch factor of anything bigger than 1 is actually a stretch. I would guarantee you if you ever write this on a test, stretch factor of 1/2, you did it wrong. Because those don't go together. 1/2 doesn't actually stretch it. Okay, so if it's a stretch factor, it's got to be a number bigger than 1. So like 1/2 would go with 2. Or in this case, 1/4 goes with 4. All right, I'd like you to see if you can handle the rest of these. This has got a either horizontal or a vertical, stretch or shrink, with a factor of whatever. See if you can handle this next one here. Try this one with the 3x. Okay, right away, should have been easy. Was it horizontal or vertical? Horizontal. And as it seems like it's 3 times bigger, so it's, was it a stretch or a shrink? Shrink. Horizontal shrink of factor 3. Wrong. Why is that wrong?
1/3.
It should be 1/3. Shrinks don't go with things like 3. Shrinks go with things like 1/3. Okay? All right. This is just a blast from the past. It's got that. But wait a minute. What's this divided by 2 doing over here? That's weird. Multiply by 2 to get rid of that. And when you multiply by 2 to get rid of that, it fixes it over here. Because this and this cancels. But when you multiply by 2 here, it squeezes a 2 right there. You see how that's a sneaky way to do a stretch? What kind of stretch? Vertical or horizontal? Vertical, stretch, factor. Do I trust that? So it's factor 2. But there's something else happening. What about that negative? Vertical, reflect, technically. Vertical, reflect. And yeah, that's it. Vertical reflection. Done. Do I have to say over an axis? No. That's part of the benefit of this. Some people that tried to guess x or y axis screwed it up. Vertical means up and down, so if you do a vertical, it's going over the x-axis. It runs kind of like the y-axis, but it's going over the x-axis. So if you wanted to say 1, you'd say over x. Okay. So that's these in a nutshell. Some kids ask this question. I think it's a really good question. They'll say, which do I do first? The negative or that? They're both kind of part of the same thing. In the negative 2, do you get that the negative 2 isn't a negative 2 without the negative and the 2? They kind of go together. So you can do them in any order you want to. Okay. Now, I will tell you, generally, it's easier to actually do the graph if you stretch before you flip. Think of it like gymnastics. If you're going to do a flip, doesn't it make sense to stretch before you flip? All right, so you don't like pop a tendon when you're doing your flip. Okay, so I will tell you, since they're right next to each other, it is okay. This can be first or that can be first. It doesn't matter, but stretching is easier when you're actually graphing on the really hard test that we have coming up in like 2 weeks from now. When we put it all together, you have to do the really complicated stretches and moves and flips and all that stuff together. Then you're going to want to do the stretch first before you flip because you won't pull a muscle. Yes? Okay, so should we trust this? This seems like, okay, just to clarify, we have to separate off the negative because it's a different thing. I know, but the negative is talking about flipping it. The 2 is talking about stretching it, and both things have to happen. So you have to think, if you're going to talk about the number that I said before, and I said it needs to be bigger than 1 or less than 1, you have to think about just the number, not the negative sign.
So if you're gonna plug in like for x example,
All right, so let's say we had an XY chart, and let's say we had some points like 2, 3, 1, 7, 2, 8. All right, so then what would we do for this one? Well, is it vertical or horizontal stuff? Vertical, so that means is it X or is it Y stuff? It's Y stuff, so we're going to mess with our Y's. Now what would we do to our Y's? Would we multiply them by 2 or multiply them by 1/2? Do we trust it or not? Trust it, and so therefore multiply them by 2 first, and then multiply by the negative. So you can multiply it by -2, or you can multiply by 2 and then the negative. So this would become 3 times -2 becomes -6. Now, if you just want to know what the picture looks like, okay, well, we know what this looks like. We know what a V shape is. Looks like this. Then what happens to it? It gets twice as big which way? Tall or wide? Twice as tall, and then it has to also what? Flip. How do I make this twice as tall? Well, this spot used to be this tall, now it's that tall. So see how it got twice as tall? And this spot used to be this tall, and now it's up. Now I can't, it's underneath this, but let's say it's there. See, here's my new thing that got stretched twice as tall. I know it seems narrower, but you got to think about it as like hands, little hands grabbing it here and pulling it up there. Another little hand grabbed it right here and then pulled it up there. Okay, so it got twice as tall, and then we got to flip it. That'd be your final answer. And you could get that by making the parent points and multiplying all of the y's, because you're out here with the y stuff, all the y's by -2. You trust it, and you do exactly what it says. All right. This is complicated. If it was simple, we'd be, quizzing you on it in like 2 days. You have like 5 days before you get tested on this stuff. So you got time to learn it. So don't stress if you're like, don't think I totally get this yet. I don't expect you to get it yet. I want you to get some of it, but I don't expect you to get it all perfect yet. We have time to kind of soak this in and figure it out. Your assignment is right here, stretches and shrinks worksheet A. And I'm going to give you a, well, I have to, let's see exactly how much time we have left here. You're going to have some time to work. So like 7 minutes? All right. So I think we can see if we could find some on here to skip, because 7 minutes of work time doesn't leave us a ton of time to work. So I'm going to pause for a second while I figure that. Okay, and I found stretches and shrinks worksheet A. I'll pull it down a little bit so they can see it at home. Right. Still pops up. But anyways, okay, that's stretches and shrinks A. So 1 through 6 is pretty easy. 7 and 8, those are going to be easy also. There's some stretches, and is that it? Yeah, that's a pretty reasonably sized homework assignment. I think it's very doable. I will cut off problem number 4. And I can't cut off 6, though. What's special about 6 that's different than the other stuff? You have dividing by 5 over on the left side. So how do you start that one? Times it by 5. Well, now you know that. We can skip that one, because it's just going to be y equals 5 absolute value of x. I did want to talk you through it, but see, that's just going to be 5 times what? Vertical stretch or horizontal stretch? Vertical. And is it really a stretch? Yes, it is. It's on the outside, so you can trust it. Sorry, I said that in a way that made you think I was misleading you, but it is a vertical stretch. It is, really, because you can trust the stuff on the outside. So that's a vertical stretch with a factor of 5. If it had been on the inside, then it would not be 5 times a horizontal stretch 5 times wider. It would be a horizontal shrink with a factor of 1/5. Remember, with the shrinks, you have to use a fraction. Shrink of 1/5. Stretch of 5. This one's a shrink of 1/5. All right, anyway, you may skip 6. You may skip, what's the other one I told you to skip? 4. Skip 4 and 6. The rest of it's due. So, one last thought. Top 20. I signed it yesterday. If you got started on it already, you were nice to yourself. If you didn't, you're piling up your work over the weekend. The top 20 is due Monday. Okay, so you got to get that puppy done over the weekend. Which version? I think I gave you 4, was it? Okay, version 4, top 20, due on Monday. Why do you care more about this one than all the other ones? Because next week is the real test. Counts in the 85% category, just like all your other tests count. Now, couldn't you get an A on this test? You could. You know what all the questions are. You already know all the questions. And if you want to relieve stress on yourself, you can have retakes on it. But it's really lame if you're still retaking this thing, you know, like 3 months from now, and other people got done with it on October 5th. You know what I mean? Just get it over with. Learn the stuff now. Okay. And that's all I have to say about that.